Have a calculator ready to go. So I just reviewed briefly that, triangles, the height can be inside. It's not actually a side length of it. It's just measured from the very top down to the bottom. And then you have a triangle in this instance where the height would be on the outside, but to get to the very top of that triangle, we would measure from the horizontal, the bottom, all the way up, always at a 90. And then a right triangle, obviously, the actual side itself is the height. Okay. So just be aware, most of our cases are going to be here. And so we did a quick example here. A reminder that sine of 90 is just 1. It's always going to be equal to 1, so sine of 90 degrees is 1. We had this scenario where we essentially at first treated it just like any other triangle. And I want you to remember my words here. At first you want to ignore the dashed line, okay guys? Ignore this dashed line. Like, try to look at the big picture, right? First and foremost, like what's on the outside. That's why I kind of sketched it out here. And I copied this down. All the information that I could bring with me, I did. And then I asked you what law could you use here. And the answer is sine law. We had to do a little bit of work to figure out that third missing angle. And then we saw we had a pair. Okay. And then we used sine law to figure out the distance from a cat to Pika, and we also found the distance from Steve to the same point. And that's, once I have, listen carefully to this part, once you have one of these slants here, that's when you can actually slice it up and focus on the height itself. So I choose, so look up here for a bit. So if you find this slant here, then I would slice it and take that right triangle with me and then copy down any information that is transferable. So this 17 degrees comes with me here. The side that I found, which is 14.72, comes with me here. I could not copy the 20 down because it goes from end to end. It belongs to the big triangle here. Okay? And so once I had everything there, I noticed I had a pair. Don't miss the fact that this box represents what? 90 degrees, correct? So that's my pair. I have it right here. And then I use sine of 17 to find, we want the width of the river, but we know that that's the height of the triangle. The same thing, right? And so 4.30 is the height here. Let's do, I like to show you at least once that it wouldn't matter which side you picked. Let's pick the other side real quick here. I'm going to zoom into that corner. Okay. If you feel like you need another go at it. Okay. So here it is. This is W. We know this is 90. Sometimes students wonder. Let me just show you one more time. If there's a 90 here, folks, there's a 90 on the other side as well, right? Like, we just don't bother putting it on both sides, but it's along a straight angle. So it's 180, right? 90, 90. But back to this corner, I'm going to copy what I know. The 7.32 would go right there. The 36 degrees goes right there. And here again, I have my pair. I'm going to find W. So sine of 90 over 7.32. And then it's sine of 36 over W. You cross multiply and divide. So that's 7.32 times sine of 36 divided by sine of 90, which we know is just 1. We're expecting it to be 4.3, right? Like, it wouldn't make sense if we get a different answer. So we just go multiply, and then I'm not going to divide by sine of 90 because I know it's 1. And there it is. It's 4.30 meters, regardless of which triangle we sliced off of the big one. Okay? Now, I don't think I assigned anything, right? So I'm going to ask you to practice this skill before I move on to my next topic. So everything is just going to be adding layers to what you've learned. Layers, layers, layers. But in it, sine law, cosine law is where it's at, right? But we might have to do some work to get there, to get to the point where we can use sine law, cosine law. Okay, so I'm going to ask you to go to page 29. And if you're done, you can keep going to page 30. You can go to page 30 if you want, but right now I'm going to ask you to focus on 29 and just answer the questions that are there. It's all one big question, really. And the bottom line is the new part will be to find the height of this guy wire that's holding up the post. Have you heard of the term guy wire? Anything that like supports a pole or a post? Like the hydro poles, right? You see the wire coming down usually has a yellow sleeve around it so you don't hurt yourself, right? Yeah, that's a guy wire. So it's going to ask you the height of the triangle in a sense, right? This, you can make a dashed line if you want, right along the pole here, but you're not going to focus on that right off the bat. You're first going to focus on everything else that's on there, whatever else I'm asking you to solve, and then you're going to find the height at the end, okay? So go for it. 10 minutes or so on that, and then I'll continue with other questions. I'll take it back and see how you did. That's interesting. Sound is coming out of the projector. All right. So in this case, I look at it, I see a pair over here, okay, because it's asking what's the angle of elevation of the wire on the left. That's what they're asking for. Remember, angle of elevation, you would measure it from the horizontal going up, right? Like that's angle of elevation right there. So in this case, let's sketch it out. I think it's worth doing that. This is 36. This is 4.7. This is 6. This is 8. And this is question mark. Let's give it an angle. We're gonna go with angle A. This is what they're wanting us to solve for. Oh, this is interesting. Could you use, this is one of the rare occasions. You could use more than one law, right? Did you notice that? Do you get the same answer? I hope so, because sometimes we need to make sure it does. So anyways, if you want to use sine law, because you saw your pair, you would go sine of 36 over 4.7. And I'm going to use side 6 to find angle A, so I have to go sine A like that. Sine of A is 6 times sine of 36 divided by 4.7. My next line, I will go A is equal to sine inverse. Okay, you want to be making sure that it starts with a 0. That's 0.7 something. I'm going to use all decimals there. Shift sine. That's 4862. Anybody use cosine law for this? Did you get the same? Ronan? Yeah? 63? 23? Okay, close enough. It's because like I would have to probably give you more decimals on the sides to make sure they're exactly the same. So we're not going to sweat it. If you use cosine law, you're fine. Maybe I will do it just to refresh you. It has been a weekend, right? I don't know what you do over the weekend. You probably just look at your booklets every day, right? A couple times every Saturday and Sunday, right? Because you're bored. But just in case, if you wanted to use cosine law, remember, you got to add and subtract two sides. Or there's going to be the three sides, but you add and subtract. The first one you want to write down is this one. Okay, the one that's across your side. And then the other two No matter, the order doesn't matter. Okay, you put them there, and then it's 2 times the first one times the second one, and there you go. Cosine of A, if you clean that up, I strongly recommend you do this in steps. It's 50.09, so I know this is going to be an acute angle because it's not negative, right? So I already know, and I kind of expect that anyways. And then it's 2 times 4.7 times 8, that's 75.2. So when I divide those two, it's 0.6 something. Angle A is cosine inverse of what I got there. Shift cos 48.23. Okay, close enough for us, right? Should be the same, but it's because of rounding that they're not. Okay, we had to be more precise when we gave you the side lengths. Anyways, don't bank on this. Okay, don't bank on that. But if it had been the case, you just choose whichever one, and you're good to go. All right. So how high up the flagpole are the wires attached? They're essentially asking us for the height. Okay. So if you go with the left side of the big triangle, we know this is 48. Okay, now it's going to be controversial, right? Because some of you are going to use this, some of you are going to use that. It doesn't matter in this case. What can we assume? We are assuming that there's a 90 here. Okay, and we've got our pair. So sine law again. I know some of you used SOHCAHTOA last year with right triangles, but I'm not going to go there because I don't want you to mix them up. So it's sine of 4862 over h. So we're looking for a side length. Oops, 4862 divided by sine of 90. So it works with right triangles. It doesn't matter. So it's 3.53. And for those of you that used centimeters, okay, I see what happened there. Did that throw you off? Centimeters and meters? Sorry guys, I didn't mean to do that. I should have warned you. It was all supposed to be in meters. Okay, all the dimensions. That's just a typo. So go up to the very top and just change the centimeters to meters. Okay, so you're not confused. Like, why didn't Mr. Dirksen convert? Right? Because technically you would convert. It'd be pretty ridiculous to have a side of 4.7 centimeters, right? And everything else is in meters. Just wouldn't work. Okay. If you use the other angle, yours will be slightly different, but it doesn't matter. I will just tell you on this side, I'll spare you the details. I'll just say height is also 3.53 meters. Okay. Let's keep going here. I'm gonna slightly. This is just something that I would expect you to know how to do. Slice up a triangle and come up with a height. Okay. So I'm not gonna have like a question specifically on this. It's gonna be probably a bunch of other work, and it's like, okay, now find the height of that triangle, or find how high up the pole the wires are attached. Something that hints towards finding the height. So let's keep going to page 32. Page 32. And so we're going to talk complementary versus supplementary. I'm going to stop